Okay, so I'm going to be going through today is kind of the essential elements of weather and kind of those key factors that we look at. So the first thing we're looking at is kind of, what is weather? So weather is what we call the condition of the Earth's atmosphere and kind of at a certain time and place. So we're talking about, the conditions outside right now. They can be observed through kind of like direct observation. It's kind of normally how we measure those. It's kind of describing the factors that we're going to go through is temperature, humidity, precipitation, air pressure, wind, and visibility. So we'll be going through, or I'll kind of go through each of these and go through kind of key factors or key information for them. So the first thing we have is temperature. So we're looking at like what temperature is and kind of how it's measured. So temperature is simply how hot or cold something is. Right, so we normally use a thermometer to measure that, and to kind of display it. We have a few different types of thermometers that are able to be used. So we're actually kind of doing the measurements. There's kind of three different measurements for temperature. The first is what we call the metric unit, and that's the Celsius centigrade that scientists primarily use. This was discovered or created by Anders Celsius from Norway. The kind of key thing to remember with Celsius is that 0 degrees Celsius is the freezing point of water, and 100 degrees Celsius is the boiling point of water. The next unit then is what we call the standard unit, or Fahrenheit. You're correct, that should be an H after the N here. So the Fahrenheit is just created by Daniel Gabriel Fahrenheit from Germany. Kind of key things to remember with Fahrenheit is the boiling and freezing point of water. The boiling point of water is 212 degrees Fahrenheit, whereas the freezing point of water is 32 degrees Fahrenheit. The last one then is what we call kelvins. And these we normally don't use in weather. They're used more in physics as well as looking at like light bulbs. So this is created by Wilhelm Thomson and Lord Kelvin because they wanted to basically know what absolute zero is. And absolute zero is the temperature at which there's basically no heat at all. So things stop moving. And when we're looking at this in Kelvin, it would be 0 degrees Kelvin, or it would also be minus 275 degrees Celsius. So that's kind of looking at the key things, some key information for temperature. And the next part then is humidity. So humidity simply looks at the amount of water vapor in the air. So as water evaporates, right, the humidity in the air is going to increase. And kind of like the opposite of that would be the condensation. So as water condensates, right, it's going to decrease. So relative humidity is another key term here. And what this is the amount of water vapor in the air compared to how much the air can hold, or we call that saturation point. And what we use something called a psychrometer. We'll see that on the next page, kind of a quick example of it. We measure it as a percentage. So if we have 100%, in air saturated, the rates of evaporation and condensation are equal, we consider that 100%. So basically the air is holding as much moisture or water as it possibly can. And that will increase with temperature. So looking at kind of a psychrometer, normally what we have here is as we consider a wet bulb and a dry bulb. We'll go through that kind of later in the week and a little bit more information on that. And kind of show how those work as well. But here's kind of a couple of pictures showing what psychrometers are. The other thing that we have is what we call the dew point. So the dew point is normally the temperature at which there's more condensation than evaporation. So water is kind of creating dew or drops, and that's when it starts sticking to objects. So a lot of times in the morning, when especially during the summer or in the spring, when it gets cooler at night, the amount of moisture the air can hold decreases. So then that what we'll see is we normally see drops of water begin forming on plants or vehicles or anything that's outside. So you can see here when air temperature drops below the dew point, water will condense to form dew, fog, or clouds. That's kind of how we get that fog and clouds, and that's the main way in which they form. Okay. So kind of some examples here you can see. So this would be, as the dew point or the temperature decreases, we create fog, or you can see here, as Rafael Nadal, tennis player, he has sweat forming on him, and it's not going anywhere because the temperature is hot enough where basically it can't evaporate anymore. And we're looking at a liquid, so you can see when molecules are really close together, they form a liquid. As they spread out, this would be showing evaporation. And here we have a desert where it has extremely low humidity or relative humidity. It's simply due to the fact that it's very, very dry, so it's getting hot, but there's no water to evaporate. So looking at the image here, we have evaporation and condensation. So when we're looking at this, we're trying to figure out, okay, is humidity increasing or decreasing? So what we can see is there's three molecules, or the evaporation is higher than condensation. So in this case, the humidity would be increasing because there's more water going into the atmosphere than is leaving it. So that's kind of how we see with humidity is basically the amount of moisture in the air, water molecules in the air. With more evaporation, we see it increasing. With more condensation, it would be decreasing. So the next thing then is precipitation. So there's kind of four main types of precipitation, which is rain, snow, hail, and sleet. And precipitation is simply any time moisture falls from the atmosphere or to the surface from clouds. So when we're looking at on Sunday, we had a blizzard, which meant we had a lot of snow. Right, so inside a cloud, there's water droplets. They collide, they form together. Right, as they continue colliding and getting bigger and bigger, eventually gravity will pull them down to earth, and they fall as rain. So rain is simply measured with a rain gauge. So the check basically measures how much rain falls in a small area, and we can determine how much rain fell. The other type, snow, for example, forms when air temperatures are low enough to turn water vapor into a solid. So basically what's going to happen is they normally will be stick like a piece of dust. Right? So as the molecules start kind of forming together, right, they form as a solid. Right? And then again, once they are heavy enough, right, they will fall. So normally we just measure these by kind of how deep it is or how kind of thick the snowfall is. And with this, there's actually different types of snowfall that can kind of factor into how much we actually measure. Next thing then is hail. Hail is simply we have big lumps or balls of ice that fall. We'll go through a little more of this in the precipitation part of the unit. But basically what we have things called updrafts, that as the moisture rain falls, there's going to be an updraft that's going to be wind that pushes that moisture back into the clouds where it's going to freeze. And this creates a constant cycle where it's kind of rising and falling, and it keeps getting larger and larger until that piece of hail is too heavy for that updraft to stop it from falling. Then it'll fall to the ground, and then you get hail. Sleet then is basically rain that falls through a layer of freezing air. So as it hits that air, it's going to freeze and become basically little solid pebbles or really tiny pieces of hail. They're small enough, we just simply call them sleet. We'll go more through the precipitation later on in the unit. Okay, clouds, we will have a unit part of clouds, so we're going through this real quick here. There's kind of three main types that we're going to be looking at. We have what we call cirrus, cumulus, and stratus. Cirrus are normally the ones that are very high in the atmosphere and they look like feathery or wispy. Cumulus are the ones that kind of produce the thunderstorms, and they appear as the kind of big piles. They're really thick, and they normally are the ones that produce storms. Then stratus clouds, stratus means layers, so they form layers, and they tend to block out the sun, and then again they produce rain. But we'll have more time to go through clouds later on in the unit. Okay, air pressure is kind of another key thing we're looking at that's going to determine what's happening in the weather. And so when we're looking at what air pressure is, it's that force of air molecules pushing down an area, so it's all that air in the atmosphere pressing down on us. So changes in air pressure normally signal changes in the weather. So whenever we see a steady or rising air pressure, that normally indicates that it's going to be clearing weather. It's going to be getting nicer. It's going to be clearing. It might be cooler, or simply it could be warming up as well. And slowly falling indicates normally there's going to be rain. So if we start seeing the air pressure decreasing slowly, there's a good chance that we're going to have rain in the near future. When it falls rapidly, that means there's a good chance that there's a storm coming. We measure air pressure with a barometer, which you can see here. It's going to be a picture of one up in the top corner. You can see, like right now, what this barometer reads is it's probably nicer weather out. So we kind of see how it shows sunny. As it begins decreasing, when we get lower, that's where we see kind of rain. And if it happens really, really quickly, that's when we get storms. Remember from the atmosphere unit, air pressure. Oh, this for a second. But air pressure and density tend to decrease with altitude. As you go higher into the atmosphere, the air pressure is naturally going to decrease. Okay, wind. We did talk a little bit about wind in the last unit. So wind is simply air that moves horizontally or parallel to the ground. Remember, it normally moves from like a higher pressure to a lower pressure as caused by changes in temperature. So as the temperature changes, we're going to see wind being created from that. Right, and the kind of tool we use to measure wind speed is what we call an anemometer, and I'll see a picture of that on the next page. We use a wind vane or a windsock, and you can see those at like airports a lot of times, right, that measure wind direction. So we're looking at these. This is an anemometer here as well as here. So as the wind blows, the air molecules are going to kind of catch into this cup. It's going to cause it to spin, and then the rate at which it's spinning, they can determine how fast the wind is blowing. Okay, one of the last key things here then is visibility. So visibility is basically how far we can see, right, based on the weather. Normally, if there's 3 or 4 known landmarks that we will use for that to kind of measure how far we can see. So air pollution, fog can cause poor visibility. So a lot of times we look at that with like fog primarily. We can also think about visibility when we're looking at like winter weather, when we have like blizzards or a lot of snow and wind, where it becomes very, very difficult to see. But visibility is basically just how far we can see using known objects. Right? Ways in which we can collect weather is normally we have like ground stations. We do have a couple of these in Fairmont. They do have weather buoys. Weather buoys are normally out in water. We see these normally in oceans, especially when we're looking at climate change. They're constantly measuring the weather to see how it's changing. We have satellites, ships, airplanes, and all these different ways in which we can collect data. Right? That's kind of some quick intro to weather, kind of some of this essential information. Right? So hope you guys got good information and have a good day.